Hello, good morning, students. Today, we will be discussing an altogether a new topic in which we are going to start Module 2 with the title Moving Towards Object-Oriented Programming. In our previous modules, we have learned how to manipulate the user interface of the IDE itself, which is Android Studio. We have also learned how to create the user interface of the app that we are going to create, as well as learn about the background regarding how Java was conceived and overall how programming languages work. So today, we will be learning about uh, various topics. So what you will learn in this chapter, you will learn to define what data types are, its purpose, and its usage, classify the different data types, define what an object is in context of programming, define classes and methods in Java and its usage, demonstrate the uses of classes and methods, and lastly, demonstrate the use of built-in classes in Java and in Android. So Java is one of the most used programming languages today. The fact that it is using an object-oriented programming paradigm is one of the reasons it is popular. Learning programming is not simply learning how to code, it is also how to create a program, and it is also involves adapting to a coding pattern or model. So what is object-oriented programming? To clarify, object-oriented programming doesn't mean that an object or a program strictly complies to what object-oriented programming is. Object-oriented programming is one of the programming paradigms, meaning it is one of the programming disciplines that a programmer can adopt. It is not necessarily that you are going to program in object-oriented programming, but rather it is a discipline that one can adopt. In this chapter, you are going to learn how object-oriented programming works and how it differs from the other programming paradigms. Of course, we are going to try to program in other programming paradigms so that you can learn the subtle differences between them. So, in object-oriented programming, concepts within the program are represented by objects. So, unlike most programming languages out there, object-oriented programming is grounded upon the visualization or the concept of objects. Most other projects are centered around how a program works. For example, procedural programming. In procedural programming, you are going to create a program based on procedures or tasks. For example, the task is about uh, enrolling a student. So there are multiple approaches to this. So how does procedural programming go about with this? So there should be a series of procedures in order to come up with a solution to a problem. Now, in object-oriented programming, they took things a bit further and simpler for the programmer. They visualize everything as an object, including the student. So how do we visualize student as an object? Most sub most objects in the natural world have what we call attributes or properties. attributes, or properties. This define what an object is. For example, an apple, or maybe it's appropriate to call this a cherry, if you will. So, what are the properties of a cherry? There should be its taste, its color, its texture, so on and so forth. That's what defines what an object is, right? It has what we call properties in it, properties or attributes. So, not only does this object have its properties, but it also has its own functions. So, what defines an object in programming is not only its data. So, the object is defined by two things. It is the data or the information that an object has and its functions or what we call in programming methods. So, in object-oriented programming, concepts within the program are represented by objects. Each object is an instance of a class, which can be seen as a blueprint or template of the object's characteristics. For example, here, let's go back to cherry. So what should be the class of cherry? It should be included in the class called fruits. So it is included in the fruits class. Now, the fruits contain, let me fix this here. So fruits class should contain the basis of the object's characteristics, which dictate for the other fruits as well. So what are the most common characteristics that fruits have, which is shared among all other fruits? It could have the taste, it could have the color, it could have the texture, so on and so forth, which is adopted by other fruits. Classes can also contain functions called methods available only to objects of that type. These functions are defined within the class and perform some action helpful to that specific object. Um, Hopefully you can see the picture here provided in the screen, but you can also see this in Module 2, Lesson 1. So here we have uh, a visualization of how a class is being made into something like an object. So here we have a hero class. It contains attributes. For example, we have hero name, hero level, the move speed, the health, the mana, agility, so on and so forth. It also contains the methods. What methods are included here? It has the interact, it has the stop, the attack, the patrol, and the move, which is adopted when we created the clockwork object from the hero class. So as a demonstration of the usage of classes, in Figure 4.1, a hero class was created to contain various data such as hero name, hero level, movement speed, and such. Each data can have its own data type like string, int, and double. Data types will be discussed a bit further. A class can not only contain data but also functions that we call methods. These methods will be only available to the objects created from the class. So wait, let me check if you have any questions. If you have any questions, You may type in the chat box or you may interrupt me at any time. So, moving on, the concept of objects wasn't only the reason that makes OOP remarkable, but also the core principles that it encompasses, which are the three main functions of OOP: abstraction, inheritance, and polymorphism. Abstraction is a process where you show only relevant data and unnecessary information, uh, hide unnecessary details from of an object to the user. For example, when you log in with your MCM Digital account, it is going to require you your username and password, but uh, after that, this information will be sent to the servers for school use. But what happens after giving your information like verification and user authentication won't be your problem anymore. So I'm sure you can visualize how your data goes through. For example, uh, you log in, with your username and password. It goes through a verification process. Then uh, you can access the website now. Abstraction eliminates the need for you to go through all of this. It means that all you have to worry about is knowing your username and password. That is abstraction. You don't want your users or end users to actually program them for themselves in order to access your website, right? That is abstraction. Inheritance is the mechanism for which an object can acquire some, if not all, of the properties of an object. Let's go back to fruits. Again, the fruit has taste, color, and texture. What if we have a fruit that doesn't taste anything? So we can create something like mystery fruit. This is the class and this is the object. We created an object from a template class. So inheritance, the difference between inheritance is that uh, we can create a class. Wow. We can create a class in which we may only choose what property of the object or the class we are going to take, right? For example, we have a mystery fruit here that doesn't taste anything. We can just choose the color and texture as a property of the fruit. Now, polymorphism is the ability to treat objects of different types in a similar manner. In other words, it means one method with multiple implementations for certain class and action, and which implementation it is to be used is decided in runtime depending on the situation. These principles will be discussed in detail in the future. You don't have to worry. I think this pops up in Module 3. So, for now, we are going to learn basics. So, object-oriented programming also defines the concepts to help with structuring programs so that they can easily be extended and evolved. So, one of the main advantages uh, of actually developing object-oriented programming is that it allows uh, programmers to reuse their own code. One of the caveats of the older programming systems is that uh, once a code has been written for a certain function, they need to rewrite it again because there is no concept of actually grouping that set of code. So, for example, if you are going to add another user or another fruit to your program, it means you have to code it again because there is no concept of classes. You need to code it again for that specific person or if you are going to enroll someone. So, it actually creates what we call as redundancy. So, now we are going to dive in at data types, Java data types. So this is one of the bases of most computer programs, data types. So Java is a strongly typed language. This means that every variable should be carefully declared upfront before it can be used. So here are there some examples shown in the monster class. So if you look at monster class, it has the declaration int, attack mean, double, armor, or Boolean is ranged, right? The data type of the variable specifies the kind of values it can be assigned. A data type tells the compiler how much memory to allocate to a variable, the format in which can be stored, and the operations can run on it. Although a variable can change value during the program execution, its type always remains fixed. A primitive data type is a basic building block supported by Java. So programming languages, uh, most OOP languages have primitive data types. Primitive data types is somewhat the data types that are being used at the most basic level of programming. So we will be discussing the primitive data types. So the first data type is what we call byte. So byte, as you may have, I think Sir Earl may have already discussed this to you. Byte is an 8-bit signed integer, meaning it is represented by each one is what we call bit, right? And a batch of is what we call byte. So in a byte, it can this 4 or 8 digits can be represented by either ones or zeros. So in a binary system, it can have as much as 128 combinations. So if we look here in our representation, it's the minimum value is negative 128 and the maximum is 127. Sir, why is the maximum 127 and 120 not 128? So let's draw this. I think you've been familiar with this in math, right? If here is the negative and here is the positive, negative 128 is in this place. So why did we end up with 127? Of course, we are going to count 0 because it is a number. So it is 128 and 128 per year as well. Is this clear to you? Hopefully it is all clear to you guys what a byte is. Now, moving on, short, int, long, float, double, boolean, and char. So, I will not be discussing short because I think you get the point of short is. Short is just a bit longer type of byte. So short is just 16 digits. That's the difference. That is short. So it can hold by just adding 8 more digits of ones and zeros, you can come up with 32,767 combinations. So now we have int, or shortened word for integer. Int is the most widely used data type for numbers because the limit is very high. It is 2 to the power of 31. So you don't have to worry. Actually, this is wrong here. This is not negative 231. It is 2 to the power of 31. Please take note. I will be adjusting this later. And this is also 2 to the power of 63. So here, the numbers are a bit higher. You notice right there, the limits are a bit higher. If we use the calculator for to get 2 to the power of 31, I think it is more than what you are going to need for your computational purposes. Long is a bit longer for longer integer data type. This is especially useful for those who want to um, create a program that involves a lot of numbers. So now we have float and double. So sir, how does this differ from int or long? Float and double deals with floating point numbers. So what is a floating point number? Floating point number means that, for example, um, 3.141591. Are you familiar with this number? It is a shortened pi. If you know this, congratulations. So, if we store this number, wait, I think I'm hearing a bit of noise. So, if we store this in an int or long, it will only save 3. You know why? Because int doesn't have what we call floating point numbers or the decimal places. So it will only store number 3. If you are going to save 3.98, it is going to store 4 because it cannot store floating point numbers or the decimal places beyond it. So for a more precise numbering, we are going to use either float or double. I hope you get my point. If we're going to save something like the decimal places of a number, you are going to use float or double. So most of the time, uh we are going to use double. So how does float and double differ from each other? So float um has a lower maximum range. It has a lower maximum range, while double has a higher maximum range between the two. If you notice, double is a 64-bit floating point integer, meaning it can hold more decimal places than a float is. But the problem between the two is that um, the more uh, the more decimal places that you are going to use for a program, the more memory it eats up. For example, this is your RAM. This is your typical RAM. If you're going to uh, save the whole pi calculation until it can, it actually, if we're going to max out, for example, double, it is going to use all of the parts that is going to require if we are not going to define how much decimal places that we are going to use. So it would be economical if we are going to use um, a bit lower precision, 'di ba? Para so that the memory would be used up easily. We are going to use less decimal places than we are going to need. So now, uh, going to the next data types, we have Boolean and char or car. Boolean, it comes from Robert Boole, whose Boolean actually holds two types of values. It could either be true or false. So this is Boolean. Boolean is most likely going to be used for decision-making systems. The ones that you are going to use flowchart for. And also for the truth tables. I think you're already oriented with the truth tables. I think you have already been uh, discussed this from your math teachers in your previous what do you call this? Previous semester. So that is Boolean. Lastly, we have char or car. This is a shortened word for character data type. So character data type stores only a single digit of um, character. For example, the first letter of your name, the first letter of your name, a number, maybe this one, or even the underscore, even the invisible space that you're going to use when you press spacebar, it is going to save a single character regardless. You cannot store more than one. So it can store only a single character. So this is what we call Unicode representations. If you're going to your character map of your computer, you can you are actually going to see this, right? So it is represented by a Unicode numbering system. So that is what uh, car is. It is storing around 65,535 characters, including those of different languages. So that is what Unicode is. Now we are going to learn how to define, uh, how we are going to use such. So literal. Let's move on to literal. So literal is a value assigned to a variable of a specific type. So uh, if you are going to follow, I would like you to open your Android Studio. Just for demonstration purposes, if you're, you can just, um, let's see. Okay. So just for demonstration purposes, I'm going to be creating a new project. Let's start with a clean new slate. for now, we are not going to program today. We are not going to program today. This is just for representation purposes. So, now we are going to manipulate the code. So, let's add a few spaces here. So, from set content view, our layout activity main, just enter a few uh, drop downs there. So, we have enough spaces for us to type. You can add more if you want to. So, sir, how are we going to use these primitive data types? If you are going to define a primitive data type, you just have to orient yourself in this blue or dark blue line over here. So for example, we are going to type our age. So in, for example, the naming is up to us. The name is up to us. So we should name my birthday. Take note of the capitalization. So it starts with a small letter. If there is another word, it should be a big letter. We call this capitalization system lower camel case. We call this lower camel case. There, for naming classes, we know you notice that it starts with a capital letter. Then another word, capital letter. We call that upper camel case. Upper camel case and lower camel case are uh, case justifications that being used in programming. So I want you to orient yourself the differences between upper camel case and lower camel case. It differs from uppercase and lowercase. Lower camel case starts with a small letter. Then, if there is another word, it should be capital. Upper camel case starts with a big letter. Then, if there is another word, it should be capital letter. So, for example, class uses upper camel case. If you are going to define an object, it should be in lower camel case. So, I'll just throw it out there because I want to be you to be oriented with that. So, again, going back to our topic, ain't my birthday. So, let's put equal here. I will tell you what the purpose of equal there is. But ain't my birthday equal mm, just the day. Let's type 15. That's my birthday. So, ain't my birthday 15. So, that's how you define uh, something. Uh, this applies for int, short, and byte. Again, the limit of byte is 128 or 127. So, uh, it isn't much useful for daily purposes. So, we're going to use int. Now, how do we type something like letter? So, we're going to define car. Car, then my first letter. First letter of your name should be, this is how you define a a car. So you notice we only used one line or one quote. One quote only. If you if there is a red line underneath, it means you are typing in error. Now we are going to use either float or double. For now, we will be using double. So for double, I think you're already on oriented with this, but it has a decimal place. So let's just type a number. For example, my passing rate is equals to 99.99. So that's how we define double. And lastly, Boolean. Now we are going to use Boolean. Boolean, I am single is equals true. So that is how you define Boolean. So Boolean then equals to true. There can only be two answers. It could be either true or false. So I hope you orient yourself with this. As you might have noticed, there is no way in how you are going to save words. So I'm going to teach you how to save words. So we call uh, words or uh, a couple of characters strings. Actually, strings is not here because string is not a primitive character as what is being written here. So I will orient you what string is. So for example, uh, we start with big letter S because string is not a primitive character. So big letter S, string, then uh, my name is equals to double quote or block quote. I hope you can follow. So this is how we are going to use uh, different data types. So this one is interchangeable with short and byte. Char cannot be actually interchanged. Double can be interchanged with float depending on the situation. And Boolean is the only one of its class as well as string. Any questions regarding this? No questions? I hope we are ready. Uh, so, again, going back to literal. Literal is assigning a value to a specific data type. So, going back here in our example, I think this is too small for your vision. So, let me... Oh, no, password. Okay. Okay, now, we're going to type, for example, we are going to type our... we can just copy this instead. So, what we are doing here is doing a literal. Literal meaning we are actually assigning a value to a data type. So, this is the name of our variable. Variable meaning uh, a value may change. That is a variable, okay? And this is the value. Variable, the value. Okay? Para klaro lang. So, in this example, uh, the equal sign is used as an assignment operator. You will learn about assignment operators here in our future lesson. So, note that literals long, float, and double can end with letters L. So, for example, here, you can notice that double can end with a D. So, that is a literal. So, for example, you can use 24.2 here. Again, going back here, this is passable as a double value. But you can also add D here. It's up to you. Though, nowadays, we don't actually use that kind of literals. So, we can just add the value directly to itself. I don't use this myself. So you are fine if you are not going to use this. So character literals, as you might have noticed, they have used this um, because characters follow what do you call this? A Unicode character map. So if you're going to the internet and search this, so let's say Unicode character map. Each character, each of those 65,000 characters are being represented by what we call a Unicode value. Example here. So each of these characters are being represented by a value. So, so this is the Unicode value. You can you can also access this in the character map installed in your Windows. As you might have noticed, there is a Unicode value. So going back in our topic, um, you can use the Unicode value, or you may also get one from the internet. For example, peso sign. A peso requires a Unicode value, or you may just copy one from the internet. Excuse me. There are also some characters called escape characters that have special meaning. For example, if you are going to type, let's go back to the code. For example, we are going to show block quote. You don't have to type the block quote again because it won't show up here. Right? It won't show up. It will rather throw an error. If you are going to show a block quote, instead of actually typing the block quote, you need the Unicode value if you want it to show up in your screen. Another one is the next line. The next line. You know what next line is? The one in your keypad that has an arrow down, then another arrow to the left. That is what we call uh, the next line. So here, this is the representation of escape characters. For example, uh, line feed. Line feed can also be equate to next line. So you can use the Unicode value or the shortcut. Example, hello. Then you can use it like this, or you may also type the Unicode value. It's up to you. But I think it's better to orient yourself with the shortcut notation because it's much easier. For example, the tab. So just orient yourselves with the shortcut notation. Now, arrays. I think this is a very difficult topic for you to be engaged with today. This is better executed uh, hands-on. So because this is your first time, I'd hate to have you uh, encounter arrays on your first day. So let's ignore array for today and we will going to discuss it tomorrow. So what time is it? So we will end our class today with operators. So operators are what makes the variables do something. Now that we have already stored our variables, as you can see here, we have already stored our variables in various uh, names such as my birthday, my first letter, my passing rate, or something like that. we need operators in order for those variables to actually do something. For example, um, what is the square? What is the square of your birthday, right? Or how do you make your passing rate go to 100%? So we are going to orient ourselves with arithmetic operators first. So most of these arithmetic operators you are already acquainted with. There is addition, subtraction, multiplication, and division. You already know this except for modulo. So now you are going to acquaint yourselves with what we call modulo. So going back um, to our data types earlier, I have already told you, right, that for example, if there are two int characters, let's call this int x and y, and the value of x is, let's say, 5. The value of y is 2. So, what if x divided by y? What would be the end value of it? What do you think is the end value in programming terms? The end value would be 2. You know why it's only 2? Anybody here who can answer this question, I will give them bonus points to their missed quizzes.
Sige,
Okay,
sige, sir.
Chavez. Chavez.
Ang 2, sir, kasi remainder siya. Remainder siya sa gi-divide mo. So, bale, dalawa lang ang 2 sa 5. Bale, 2 na lang yung remainder. I-disregard na lang yung 1 na naiwan. Am I correct po?
Okay, another answer. Why do you think the answer is 2? No other answers? Sige, parang okay, Solis, answer.
Sir, I'm guessing. Okay.
Sige.
Is it rounded? The answer? Round off? That's why it's two.
The answer is correct because it is of the integer variable.
Yeah.
Again, integer stores only whole numbers. So it doesn't store any what do you call this? Any what do you call this?
Decimal.
Any decimal places. Also, the other answer is that uh, it only does what it asks you to do. It doesn't actually ask about the remainder if you're going to divide using a computer. So that is for the modulo operator to go. So for example, again, going with 5 divided by 2, the answer will always be 2, right? But if we are going to do this like 5 modulo 2, which is represented by a percent sign, the answer will be 1. So, the purpose of modulo is it counts the remainder of a division operation. So, for the offline learners, I actually have them do this as a, ano no, activity. So, let me just exhibit what I have did last night. Wait. Give me a few minutes. We will end with uh, arithmetic operators today. You don't worry. So now that the phone is on, disconnected. Okay. So, as an example here, let me run this program. You will also be creating one yourself. Don't worry. So this is a basic calculator. So let's go back with that 5 and 2 analogy again. Let's say operand 1 or x is 5. Then operand 2 is 2. If you're going to divide it, the answer would always be this 2.5. It actually showed 2.5 because what we have used for the data type is double. You can you see the characters in the screen? The words, or is it too small for the screen? Can you actually see? Okay, I'll just upload this in YouTube later. So we are using double here. So it actually showed 2.5. But if we want our remainder to be a whole number, we are going to use modulo. So it shows up as 1.0. So if we are going to use int for this, the answer would be 3 because it rounded off because it is an integer variable. So the answer would be vastly different from what actually is the actual answer. So there is some considerations in how we are going to choose the correct data type for each of the problem. So going back, this calculator actually has the 5 basic operations in a computer. 5 basic arithmetic operations. The addition, the subtraction, the division, the multiplication, and the modulo. Please take note of the characters being used. For example, division uses a backslash. Um, Multiplication uses this. Then modulo uses a percent symbol. Okay. So as you can see here from our from the code, I'm going to copy one, then paste it to Notepad so you can see it. So as you can see, this is how an operation works in programming. Simple as that. This is only a single line for the program in order for it to run. Now, um, so for this, I think this wraps up our lesson for today. We will be discussing tomorrow assignment operators, uh, logical operators. There's even a truth table here. This is already uploaded in the Blackboard. You can access it in Module 2, Lesson 1. There's already, you can see this here. There's a logical operator for the truth table, bitwise operators that we won't be using, and a quiz that, don't worry, it's only for the offline learners. So, before we conclude our class today, any questions? I know our topic today might be a bit confusing for you guys. So if you have any questions, please type it out. No questions from the audience?